not lose that. Okay.
Right. So we should be live now.
All right.
Give it a couple of minutes for people to show up. Right. So we should be live now. All right. Give it a couple of minutes for people to show up. Uh-oh. Right. So we should be live now. Give it a couple of minutes for people to show up. Uh-oh. Right. So we should be live now. Give it a couple of minutes for people to show up. Uh-oh. Right. So we should be live now. How do we stop this?
That was fun.
Well, I just unmuted. Is it still going on?
I don't think so. I think it stopped.
There is a delay there, but I don't know where.
I don't think so. I think it stopped. Oh, snap. That's a bad one.
There is a delay there, but I don't know where.
I don't think so. I think it stopped. Oh. Testing. Now, how will we know when there's actually live people watching, Wences? Do you get that information? Wences, you there?
I do get that information. I'm trying to eliminate things here to figure out why we're getting that echo.
Oh, okay. Right on.
So we can get rid of it. But we have 2 people who have joined already.
Okay.
So I'll just say hello. Welcome. Who is out there? Yeah, because this thing tells me who joins, but it doesn't tell me. I mean, it tells me the number of people, but it don't tell me who those people are, right?
Okay.
So we have 2 people who have joined via the YouTube. There's nobody on Facebook, and I don't think there's anybody on Twitter either. But we are live streaming to those platforms.
Okay.
So to all those out there, thanks for joining, and I will go ahead and get started here. Today we have Dave from HashiCorp who's going to be talking a little bit about Terraform and Packer, so that we can so he can educate me and everybody else who wants to learn more about this stuff and how it works and how they play together.
Hey, Wences.
Yeah.
Tim has slacked me and said he is not getting an audio feed.
Oh, he is not getting an audio.
No.
Oh, wow.
So let's. The heck?
I don't know why he would not. I'm going to say, can anyone hear me?
He says he's on YouTube.
He's on YouTube.
Yeah, and no audio feed on YouTube.
There's no audio in this feed. Well, let me click on YouTube here. We'll click on edit, and it says that we have 3 of them. And we're not muted, and you're hearing me, but he can't hear us.
I'm hearing you.
I am on the...
Okay, Josh is on YouTube, and he can hear you.
Who is?
Josh.
Josh is on, and he can hear us?
Yeah, so maybe it's Tim. Maybe it's Tim.
Okay. If Tim is watching this on...
Oh, Tim's got it now, he says.
Okay.
It was all Tim.
All right. Well, guys, welcome. And I'm sorry. I guess there's another guy, Boo Pati. Oh, I can't hear, so you can hear me. Well, welcome, Boo Pati. I'm sorry if I'm mispronouncing your name, but thanks for joining, and thanks everyone else who is joining us on our live stream today. We try to do this once a month, and sometimes we're trying to do it on the 3rd Thursday of each month, but sometimes that doesn't work out. But we're trying to do these on a regular cadence of once a month. And we're trying to do a quarterly meeting, in-person event. So like last month, we were at the Cidercade, which was a retro games kind of thing with a bunch of cider. So good stuff. Sorry if we missed you at that event, and if you were there, thanks for joining us then. And then I guess we'll try to do these once a month, and then, like I said, a live event once a quarter to meet and greet and get some beers and talk good stuff about HashiCorp and what's going on and the different platforms that are being supported out there. And so, like I was saying earlier, thank you, Dave, for being our speaker today. And Dave, you want to give a short introduction of yourself and what the talk is about, and go ahead and get started.
All right. So I am Dave Randolph. I am a solutions engineer at HashiCorp. I have done a lot of things in IT. I've been a developer. I've worked with infrastructure, and I hold a current CISSP. Do like to talk about security things. And today I'm going to be talking about Terraform under the guise of defeating Professor Chaos. All right, so we'll skip a few slides here because this is kind of a generic deck. So I'm going to tell you a little story here. In the show South Park, Butters Stotch takes on the persona of the evil Professor Chaos. And he starts out, he causes some mild inconveniences. Nobody really notices anything. But after a while, his power and his influence grow. And he is able to start causing much greater damage to the town. And I feel like cloud initiatives can follow this pattern, right? I think that Professor Chaos greenlights teams to move into the cloud, right? And they start out slowly. They push a server here and they push an app there. And before you know it, they've got stuff provisioned all over the place. There's no regard for consistency. There's no regard for security. And there's really no regard for cost until the bill comes in. And so at that point, it is chaos, and it's very difficult to get control of. So we will call this early chaotic stage tactical cloud. And I'd just like to mention, if you have any questions or comments, if you'll put them in your chat, Winsys will be monitoring that, and we can pick those up and talk about them. So let's quantify the antics of Professor Chaos. So the first stat we've got here is that 21% of organizations that we surveyed experience negative cyber events due to a non-sanctioned IT resource, right? And so that means something that IT didn't provision, so there was no oversight, and it's just sitting out there. The next stat is that 65% of all security issues in the cloud starts with a misconfiguration of resources. Maybe they have a variable wrong in a config, or they didn't get their permissions set down quite right, and then it opens up your infrastructure to a breach. And then the third stat is that, depending on who you ask, between 30 and 70%, but anyone can provision infrastructure. And so these organizations are overspending pretty terribly because they don't really have a cost control strategy. Now, Professor Chaos would have you believe that, you know, infrastructure as code is the answer to this chaos. But really, infrastructure as code is just a starting point, right? Because if you're not careful, what you really do is you enable your teams to deploy even faster, more stuff at a larger scale, still with no oversight. And so, you know, great, you've got infrastructure as code, but you've invited Professor Chaos to walk right back in the door. So what you need is you need someone to come in and stop Professor Chaos so that your cloud teams are using, you know, known good code and images. They're deploying with a baseline of good security and compliance, and they have an understanding of what kind of costs they're incurring before they begin to deploy at scale and speed. And this is the only real way to defeat Professor Chaos. So we'll call this lack of chaos industrialized cloud adoption. In order to move into this newer and better stage, we need a cloud operating model. And that cloud operating model needs three characteristics that we're going to talk about today. It needs to provide a golden image workflow that eliminates all the untrusted and untested code. And that's going to be a big theme of what I'm going to talk about and show you. Is we don't want anything that hasn't been tested and hasn't been blessed, okay? We need an extensible system that can work with any environment and tool set, and we need a cloud operating model that incorporates lifecycle management as a fundamental concept. All right, so we'll get into detail about these, but this industrialized cloud adoption is going to allow you to focus on generating profits. It's going to help you grow your business, and it's going to help you get ahead of your competition by focusing instead of focusing on underlying systems, right? You're going to be able to move, your developers are going to be able to deploy, and they're going to have these guardrails in place. Companies who can achieve industrialized cloud adoption find that a common cloud operating model enables them to have platform teams. And we're very big on platform teams. These are the teams that dictate what your users can or can't do. They establish those guardrails for your development. And then they have a central control plane across all the infrastructure for visibility and management. Any questions, Wences? Any comments?
No questions right at the moment.
All right. So a little bit about HashiCorp. We make tools to do just these things I'm talking about. We enable stable, properly secured base images. We enable automated deployment using infrastructure as code, and we enable governance features like cost estimation and security and compliance policies that get evaluated before you even deploy. All right, and the tools that do this for you that we're discussing today are obviously Terraform with our Sentinel policy engine, kind of in the middle. But before you even get to Terraform, you need to talk about HCP Packer, all right? Because what HCP Packer does is it's going to allow you to build these golden images and really manage them. All right. So Terraform, right, is our engine to accomplish infrastructure as code. Oops, that's a to-do slide. Look at that. You write a declarative specification for what your infrastructure should look like, right? We have a YAML-like language called HashiCorp config language. Terraform is going to take that as input. It's going to solve your dependency issue, and it's going to deploy your infrastructure into the real world. And then, like I said, it's going to use the golden images that are published by Packer. And then it's going to use Sentinel on the back end to put those guardrails up. So I'm going to talk a minute about how Terraform actually meets those goals of industrialized cloud. Okay. So goal number one was golden images. It would be on the slide if I had realized this slide was incomplete. And this is achieved in Terraform via multiple routes. So the first, like I mentioned, is Packer for image management. Lets you build your images and then publish those images in a sort of a blessed configuration. Okay. A second route to achieving golden images is integration. Can y'all hear my cat? I'm going to have to murder a cat. You need to be quiet. A second route to achieving golden images is integration with version control, right? So multiple developers can collaborate on development of Terraform code by linking Terraform to a common VCS platform. We support things like Bitbucket, GitHub, ADO. And the Terraform code can then follow a standard dev QA prod testing and deployment pattern with gates such that only your blessed code is deployed to production. And then the final route for golden images is Terraform's private module registry. And the idea behind this is that your platform team can publish tested and validated Terraform code that the rest of your organization can safely consume. And you can even make it a requirement that all new code has to be based off of modules in the registry. So you're not reinventing the wheel. Your developers, instead of saying, well, you know what, I need a network, and they start building a network willy-nilly, and who knows if it's really secure, you can give them basically a network template that they can customize to an extent for their needs based on what you allow them to do. But you'll know that when they deploy one, it's to your specifications. All right, so goal two is extensible resource system, right? We talked about the idea that there's a larger ecosystem. Terraform achieves this through what we call providers. And there are plugins that allow Terraform to interact with the world around it. And we have a current list here that I'll pop up on the screen right quick. Okay, so let's see. Okay, so today we have 2,492 providers for Terraform. So that seems like a fairly extensible ecosystem, right? And our API is open, so more can be developed at any time. Most of the major vendors support a Terraform provider for their products. Goal number three is lifecycle management, and that's achieved by the nature of the idea that of immutable infrastructure, right? And Terraform rigorously applies this. And this is the idea that once you've deployed something, you do not make changes to it. If it has to change, you throw it out and you redeploy from a known tested configuration. And so, the question that pops up is, well, why not just tweak it here and there? And the problem is doing that at scale becomes problematic, because what if your tweak didn't quite work on a few places, right? If, let's say, you've got 100 instances of something and you're going to run this upgrade script across them, and well, it worked on 87 of them, but you got 13 that for whatever reason it hung up. Now you've got these weird zombie intermediate states out in your infrastructure. Who knows? Do they work? Do they not work? So if you just throw them away and redeploy from a known tested image and configuration, you don't have these problems, okay? And then Sentinel on the back end is going to prevent the deployment of infrastructure that does not conform to your predefined governance policies. So that's an immediate life cycle, because you keep the life cycle from getting started. And then when you're done with your infrastructure, you destroy it, okay? And Terraform knows what it deployed, and so it knows that it can destroy it and make sure there's nothing left over. And that's what Terraform is in a nutshell. So just to mention real quick, we have some Terraform customers that have been partnering with us for a while to help achieve their own business outcomes. And JP Morgan is one of those customers. they had some key goals around standardization of their infrastructure provisioning, and now they have developed an industrialized, cloud unified approach to doing automation with everything they need. And Terraform is even listed in the JP Morgan Chase Hall of Innovation. So definitely a model that works and works at scale. And it's a model that Professor Chaos is not real happy about. All right, so at this point, I'm going to kind of get off the slide track here for a minute, and I'm going to start talking about Packer. Can everybody see Wences? Is this font big enough on my terminal here?
I think you can make it a little bit bigger. Any comments from everybody else? Would you like to see it a little bit bigger?
I can go to 36. How about that? Whew, that's a big one.
Yeah, right. That's good.
Okay. All right, so let's look at a Packer file for a minute. So what Packer does is it lets you build images. It pretty much does one thing and does it well, right? It's like that surgeon guy in MASH whose name escapes me. He did one thing, he did it well, and then he moved on to the next thing. And so what Packer does well is it makes images, and it can make images across different environments, okay? So the idea is, down here, I have my important things that I want to get done when I build this image. Let's say I need an Ubuntu image, but I need one in VMware, and I need one in Google, and I need one in AWS, and maybe I need one in, GCP. Well, I don't want to have to go slog through all the mechanics of getting those things built and making them work. What I want to do is say, hey, Packer, take a base Ubuntu image from each provider and do these things to it, and then store it back as a new image that I can use later. All right. So that's what Packer is doing here. And in this case, I'm only doing one in this particular demo. I'm starting with a base right here. And I'm saying getting it from Amazon. And I'm saying pull down a base Ubuntu image, do this stuff to it, make me a new image. Okay. And that's, in and of itself, that's very useful, right? But that's not really the whole story, because what we're going to do is we're going to add the HCP part of Packer into the mix. And what HCP Packer, that's our HashiCorp Cloud Platform Packer, does is it's going to give us a registry where we can publish these images. So let me show you how that works right quick. I'm going to go over here to HCP Packer, and Packer has it has the concept of a bucket. Now, a bucket corresponds to your images, for example. In this particular case, I've got 3 buckets or 3 images, okay? And so, I've got a base image, and I've got a web app image, and I've got a Windows base image. But the interesting part here is over here, you can see that maybe I've got multiple platforms in a bucket. So in this particular case, I've got a base Ubuntu image sitting over here in this bucket, but I've got it built for AWS and GCP. All right, well, so then what can I do with that? So if I look at one of these, Packer has the concept of iteration. So every time I do a build, right, I'm going to create a new iteration, and the count just goes up, build 17, build 18. So every time I tweak it, there's a new build, and Packer keeps all the history of all these builds. And then Packer lets me publish those. So what you're seeing here is a set of channels. So I have set up channels for dev, QA, and production. And on each channel, I've specified an active iteration to use. Okay. So on production, I'm using iteration 5, and On dev, I'm using iteration 7. Now, what I don't want to do is probably tweak this live in my demo, so I'm going to leave it alone. But essentially now what our consumers of these images can do, they can consult HCP Packer, and they can find out, they can say, hey, you know what? I'm the dev environment. I'm going to go query the dev channel for the Acme base image, and then I'm going to use that for further development, okay? So it's a nice way to ensure that your users don't have to, your users who are consuming images don't really have to know anything about the images they're consuming. They don't have to know that, you know, iteration 5 is the current build. They just have to know I query the production channel and it points me to the image, which is super cool. One other thing to note is that Packer is not actually storing the images. It's storing metadata about the images, right? The image is stored in wherever the image started out at. So if your base image was an Amazon AMI, when it builds the new image, it's going to store it back as an Amazon AMI, and it's just going to publish that metadata. So you don't really have security concerns around securing the image itself. I mean, obviously you want to, you know, lock Packer down to only the people that can get to it, but you don't have the added hassle of, oh, now I gotta, you know, I've got my special code stored in this third-party tool, because it's not there. If your cloud environment is secure, your base image, the actual image itself, is as secure as you've made it. Okay, so let me show you another example of some Packer here, which is a little cooler, because what I've done now here is this is some Packer code, right? It's written in HCL, and we're going to set some variables. Those things aren't really important, but this kind of is right here. So this is where what I'm going to build with this script is I'm going to actually build a useful server, okay? And this useful server is going to have a web application on it. So I don't want to start with a raw base Amazon AMI, though. I want to start with one that's, you know, been blessed by my security team. This idea of golden images, right? So remember, we saw the base image that I was building a minute ago, pulled down, you know, whatever the you know, Ubuntu AMI base image from Amazon is. But then we did some updates to it. We made sure that, you know, all the packages are updated, and we made sure that it had Apache running on it or installed on it. So now we're going to pretend that that image is the one that, you know, has been blessed for all further image development. And so now that I want to actually, you know, create an application server image, I want to use that blessed base image. And so it's just as easy, essentially, as a few stanzas here, right? So this stanza is saying, go look in the bucket name base, which is this variable. So go look in the Acme base bucket and look in the channel base, which is, let's see what channel base is. Channel base is production. So it's saying go pull whatever the production base image is. And we're going to use that as the underpinnings now to build an application server. All right. So down here, we've got a lot of, you can add, you know, infinite metadata to these things, or near infinite metadata. I'm sure there's a limit. I don't know what it is. But we're going to add, you know, here's our owner, and are going to, you know, specify all these things. And these are going to go in the Packer registry to help us, you know, understand what's in our image. And so the next thing we're going to do is we're going to copy some files from locally up to the app server. So Packer's going to actually instantiate an AMI, right? And it's going to do things to it before it shuts it down and creates a new AMI. And so these are the things that it does. So you can have arbitrary amounts of scripts to do things on these servers, right? We can upload all kinds of stuff onto the application server itself to actually customize it now to do our thing. So it gives you a nice way to do all this. Now for time, I'm not actually going to go through the building process. What I am going to do is I'm going to go over here and make sure that I feel good about my dev channel. I think I do. Let's see here. See if there's any newer. No, that is my most recent iteration. Okay, so I'm in good shape there. So let's go talk about Terraform for a minute now that we've got Packer. Wences, do we have any questions?
No, not yet, but I'm asking for some.
Okay, all right. So let me go back to my dev workspace here, and let's kick this off. It's been a while since I've run this one. So I'm going to start a run here, and then I'm going to go back and talk about Packer a little bit. Let me just make sure my plan's going to work. Stand by 1 second. So this is pretty cool stuff, though, because what I'm about to show you now is I'm going to talk about Terraform and state file management. And I'm going to talk about some enterprise features, right? So in Terraform, we've got 3 main verbs. We've got plan, apply, and destroy. There's some other ones, but we're not gonna get into that right now. So what plan does is it processes your Terraform code, and we're going to look at some in a minute. What apply does is it actually reaches out to the providers and instantiates your real world infrastructure, okay? And then when that's complete, it writes a state file, which is a very important file, all right? Then we have Terraform destroy, which tears down all the infrastructure recorded in the state file, right? So that's how, oh, my key pair already exists. Somebody's been playing in my environment, most likely me. Let's go find a different workspace right quick. Pretty sure this one still works. All right. I may have to pop into AWS and kill a key. So y'all just bear with me here. So anyway, destroy is going to tear it down. And so that concludes your lifecycle management, right? So let's talk about the state file for a minute, okay? So I mentioned that state files are created at the end of the apply, right? And it's a very important file because it contains all the information about what's been deployed, and then that gets used to determine what should happen in future applies or destroys, right? So you don't want to go tweaking your infrastructure that Terraform has deployed. Now, we do support drift detection in Terraform Cloud, which is nice because it will tell you if someone has been playing in your infrastructure. But as a general rule, once you've deployed things with Terraform, again, you don't want to go tweak them. You want to tear them down, redeploy them. All right. So if you do an apply, and this is the trap of Terraform open source, right? So Terraform open source does not serialize your state file, and you have to have a state file to do an apply. Okay. Well, there's something wrong with my demo here. So we may have to punt something here in a second, and that's fine. We'll go back to this guy right here. Let's try this one. Apparently, I've got a duplicate key somewhere that I made out of band. I did not follow my own advice. So anyway, if you don't have the latest state file and you start having Terraform do things to your infrastructure, you will end up in trouble because you will most likely cause an outage. So that's one advantage of Terraform Enterprise and Terraform Cloud is it centralizes the state file and then it serializes the applies. If I come in and try to do an apply while someone else is doing an apply, it will stop. It will put me it'll pause my run, and it'll make that first run finished before my run can proceed. So another thing about state files is they contain secrets, okay? So this makes them a little bit dangerous. You don't want to check them into version control. And you really don't want to pass them around on the network because, you know, things on the network can get stolen. And so we don't want that to happen, okay? So what do? You get Terraform Cloud or Terraform Enterprise, okay? And then another thing that Terraform can do to sort of protect you is you can then integrate with version control. I'm going to show you how that works in a minute. All right, so let's find, I think this one's going to run good. It's a good thing I had more than one line around. Let's go in here and look at some Terraform code then. So this is the code we are running as we speak. Let's see, we're running the dev workspace. So what I've got here is I've got a GitHub repo, and I've got 3 little branches in it called dev, QA, and prod. And those can be attached to different workspaces. So I can do my dev work on my dev branch, deploy it with my dev workspace, test it out. When it's all good, I can promote those changes up to QA. So let's look in my dev workspace right quick. Now I have got some things in here. So first thing I'd like to show you is the concept of variables. So in Terraform, you can create variables, right? And so I've got all these variables that describe how I'm going to deploy this infrastructure. And let me just check on this infrastructure. Good. Hey, we got a good run. Look at that. That's exciting. So, you know, we're going to have our subnet name. I've got my, you know, my project in GCP. I've got my private IP for my VNIC. I've just stuff, right? But I've also got my E2 micro instance. And this is my favorite example of why variables are good. In my dev workspace, maybe E2 micro is fine. I can deploy it. I can test it, can make sure it's working. But when I want to go up to prod, maybe I need a larger instance. Maybe I need more CPUs. Maybe I need more memory to actually support production. So rather than having to really make any changes, I simply change that variable for that workspace. Because in Terraform, at each workspace, you can override these variables, right? I can change what's in these variables on a per workspace basis. And that's pretty cool. All right. So then we're going to deploy some, oh, that's not the one. Where is it? VPC. That's what I'm looking for. So here's code to deploy the network. This is going to make me a VPC, and it's going to set up a little firewall rules here so we can get into things. And this is an example of something that you might want, your platform team might want to make into a module. Hey, you know, developers, here's your template for a VPC. These are your minimum requirements. Use this code as your base. Okay. Then we have our actual web app. And so, you know, our web app here is going to deploy. Let's see, where is it? Yes, our web app here is going to look, this looks very much like what we saw in Packer when we were building our app server. You know, we're going to look in Packer and we're going to pull down, you know, this data from Packer to figure out what image we deploy. And then when we actually deploy it somewhere, let's see, where is that? It's going to be, it's in here somewhere. There it is. We're going to use this image that we get from Packer, right, as what we deploy. All right, so let's see what else we're going to show you here. Let's show you Sentinel then. So I'm going to change repos right quick. So Sentinel is our policy as code engine. Okay. let's see, I believe it is in here. Yes. And so what you can do with Sentinel, we'll go back to Terraform right quick now. We'll look at that run that just ran. So right here, there's a section that says policy check passed. So I have set up some policies for this Google workspace to, make sure that my infrastructure gets deployed to my specifications, okay? So I've got one to enforce some mandatory labels, restrict GKE clusters, require DNS support. The sky is the limit on these things. If you can envision it, and if you can quantify how to check for it, you can get it done. And you can write these policies to restrict whether or not this infrastructure gets deployed. You can even call out to a third-party API. So, just as a quick example here, let's go into governance third generation, GCP, and restrict GKE clusters Sentinel. So it's not a declarative language. I'll start by saying that Terraform is declarative. You tell Terraform, this is what I want, and Terraform says, you know what, I'll figure out how to go do that for you. Hold on a minute. And it goes and does it. Sentinel is a little bit more imperative and procedural, right? So you have to go through here, but we're going to do things like find all the GKE clusters in this deployment, and then we're going to look for the ones that have an invalid machine type. And then down here at the bottom, we're going to return, whether or not this giant Boolean condition is true. So that gets fed back to Terraform, who can then do one of three things with it. One is it can advisory. And so advisory is like a warning. If you're an old C programmer like I am, you may have run into a few warnings in your life. Advisory just says, hey, I'm going to print a message. So if I scroll up here, at some point I'm going to get, instance has labels. It should have had one of these items, name, TTL, or owner. So that gives me a little context about what I did wrong. Now, the other two that I don't actually have turned on in the interest of, not making the demo last all day, you can do what's called a soft fail, basically, right? So you can stop the run, and an administrator will have to override it if you want to continue that run, okay? And then there's a hard fail or a hard block, which is a failure that nobody can override. If you want to get around it, you're going to have to go change your code. And this is totally configurable. Inside of Terraform, you can set, each policy. You can say, okay, this one is going to be, a hard stop, and this one's going to be a warning, and this one's going to be, whatever. So that gives you those compliance and governance guardrails, which are super nice. Another great feature here is the cost estimation. So this is telling me that, if I deploy this, my monthly cost will go up $6.31. And you guessed it, the cost estimation can be tied to a Sentinel policy. So again, you've got that life cycle management, and a really important part of life cycle is don't let something out of the gate unless you know you want it and you're ready to have it, right? So you can set a cost threshold and say, you know what, you can't deploy a workspace that's going to, add, more than $50 a month to the bill. And then your developers can go do their thing, but they've got to stay inside of their threshold. All right, let's see what else we want to talk about here. We do provide a whole bunch of starter policies. This repo that I'm looking at is public. We've got some GCP functions. We've got a whole bunch of AWS functions. So here's some, you can IAM policy actions. You can have policies about whether you can have a quad zero in an ACL for your VPCs. You can lock down your S3 buckets. You can do all kind of great things in here around policy, right? And that's pretty much what I came to show you. I mean, I can, tour you through the interface. One nice thing you can do, I'd rather not tour you through the interface, but I could. You can actually set this up so that if somebody makes a change, it will kick off a run. So let me actually demo that for you. I'll go back to my my original repo here. Let's see, Terraform Packer demo and Terraform GCP. All right, so if I'm gonna go, what was my branch here? We're in dev. Okay, so I'm gonna go to dev and I'm gonna edit my web app. I think it's my web app. Yeah. And I'm just gonna add a tag. So I got some tags here. Robot vacuum. Say that because a robot vacuum is woken up in the background. It's going all over the house making noise on me here. Trying to talk over it. So I've committed that little change here, and I'm going to go back, and here any minute we should see a run kick. Oh, there it went. Run kicked off. So that's a nice feature. You can, in your dev environment, you can definitely say, hey, you know what? When somebody, commits or we do a pull request or whatever, just go apply it and we'll test it, right? You don't want to do that obviously in QA and prod. You want to gate that. You can also, though, you can set it to run speculative plans where it'll run a plan so you can see what might happen, but you don't necessarily have to apply it. Okay, so let's see the details of this run just for fun. So what we know here is that this has changed. Now, I did mention that there is this concept of immutable infrastructure, but there's also pragmatism is one of the core HashiCorp values, right? Like if you're going to add or remove a tag from an instance, it's not real pragmatic to tear that instance down. So there are a few cases where it's not going to do a tear down. It's just going to change the tag, right? So this is one of those cases. So we'll go ahead and confirm and apply that. And we will run it. And we'll let it apply. And then one other thing you get from Terraform is you can specify output, right? You can specify this is my interesting output. So let's see what's behind this URL right here. This will be interesting. Crosses his fingers. It's a cat. So our web app actually works. So we have at this point taken a golden image from Packer. We built a golden image, right? We used that golden image to feed Terraform. Terraform took that golden image, deployed from our infrastructure, stored in our version control repository, did some cost estimation on it to find out, are we about to run up a $10,000 bill? Or are we going to run up a $6.03 bill, right? 3-cent bill, which is more my speed for these purposes. Then we subjected it to some policy checks, right? So again, life cycle. We actually then Terraform goes out and it instantiates and deploys these images. And the last thing I'm going to do is I'm going to tear it all down because I don't want to pay $6.03. So I'm going to queue up a destroy plan. I put in my workspace name, and in a minute, all this one infrastructure, but the VPC and all kind of the supporting hardware and rules required to get this thing spun up and off the ground are going to disappear, and they're going to get off my bill. So that is our golden image workflow in action. Right, and it's pretty powerful. I personally think that armed with these tools, and there's a few other features in Terraform Cloud and Enterprise that are useful for this, but these are, in my opinion, these are the high points, right? I think this defeats Professor Chaos, right? He may get in yet, but it's not going to be through your infrastructure. So with that, I would open the floor to questions and or turn it back over to Wences.
Yeah, we didn't get any questions, but what I would like to do is thank Dave. Great talk.
Thank you.
Stuff. I put links in there to the different platforms that you moved around to, from Terraform to Packer to the Terraform Cloud and some things like that, and to Sentinel. So I put those links in the chat, guys. So if y'all want to learn more about that, feel free to go click on those links and then ask some questions in the Discord. And again, I'll put the Discord in the chat there also, so you can just click on it to join. And we're pretty much done here. But before we end this recording here, I want to experiment on something that we use something called StreamYard to do the streaming here, to stream these things live. And I don't think there's a plugin for StreamYard for the Discord, but I'm going to try to share my screen so I can show you the Discord, and then you guys go over there. And then after we close out here, if you want to do the after party kind of thing, we can go and chat about it, and we, in person, if y'all would like to do that. So real quickly, I'm going to share my screen here. Share screen. Okay, so I am sharing the actual Discord. So this is the Discord, and if you click on that link that I posted in the chat, it should take you there. And so once you're inside of the Discord, what you need to do is you need to come down to this thing right here where it says Community, and there's a little tab here that has a little speaker and it says Water Cooler. Click on that, and then you'll be able to join a live session where we can see each other and chat, in person. So I'd like to thank everybody for joining us today. Thank you again, Dave, and we'll see you guys next month. And if you want to continue to the after party, just join the Discord and go over to the water cooler over here, and we can start chatting. All right, thanks, and have a great day. We'll see ya. Good stuff. Thank you, Dave.